Okay, good morning, scholars. This is our first lecture, so hang with me. I will do my best to be short and sweet and really try to make it as much like a normal teaching experience that we have in the classroom. So um, hopefully you've copied out these notes so that it's just like in the class where you come in and pick up whatever it is that we're going to be working on that day, and you can follow along right with me. And so here we go. So we spent a tremendous amount of time talking about limits, and so today is our big day. We're starting chapter 2, and we're going to start to understand why limits are so important, because they allow us to define things in calculus and understand why it works the way it works. So today we're talking about the slope of a tangent line. Okay, and in order to talk about the slope of a tangent line, we're first going to find the slope of a secant line. And you may or may not remember from geometry, but a secant line is just a line that touches a curve in two places. Okay, so you can see this is our curve that we're working with right here. I'm going to try to put it in red. So this is a curve. Think of it as almost like maybe part of a parabola. Okay, so this is the curve we're talking about. All right, and so the average, as hopefully you got a little bit from that video that I asked you to watch yesterday. I believe that was on Khan Academy video. But basically, if I wanted to find an average rate of change from here, x, okay, to here, okay, x plus h. Okay, if I wanted to find the average rate of change between these 2 points, well, I could just connect this point in the curve, this point in the curve. Okay, then I would have the ordered pair for each, this point and this point. Okay, and then I would just find slope, use the slope formula to find that. Okay, so in the end, I'm just going to tell you right from the start so you know what it is we're doing in the end. What I'm really interested in figuring out, okay, is what is the slope of the tangent line at this point. I want to know what is the slope of the tangent line, the line that touches this curve at exactly one point, at that point. That's my goal, okay? But there's a problem. The problem is in order to find slope, you need 2 points. So I'm still trying to find the slope of the tangent line at this point, but I need 2 points. So I choose this point, which would be, this point would be the point x, f of x, okay? So that would be one of my points, the point x, f of x, okay? But then I need another point, okay? So if, in order to find slope, I need to have another point. So I said, okay, well, in my second point, I'm going to choose some point, and remember we were doing x plus delta x, or x plus h, okay? Well, let's say that h value, so what I'm going to add to x, that h value is right here, okay? So that would make this point, if I was trying to find the slope between this point and this point, it would be x, f of x, and then it would be this point, which is x plus h. Remember, h is just some value that I'm adding to x, plus, and then the y coordinate here, as you can see over here, it would be the function's value at this point, x plus h, which would be f of x plus h. So now I have 2 points, okay? So I have this point, xf of x, and I have this point, which is x plus h, f of x plus h. So here's my 2 points, okay? The beautiful thing about this is, it's going to be on YouTube. So if what I'm saying comes very easily to you, you can speed me up. if what I said doesn't make sense, which I think with this introduction, you may need to listen to parts of it more than once. And if that's the case, something you can't do with me in class, just rewind me and listen to what I said over again if there's a piece of this that doesn't make sense. Okay, so here we go, back on task. So I'm trying to find the slope of the secant line. Okay, I'm trying to find the slope of the secant line, which is this line right here. Okay, these are my 2 points. I know that slope from back in Algebra 1 is change in y over change in x, or y2 minus 1 over x2 minus x1. These are my 2 points. So y2 minus y1 would be f of x plus h minus f of x over x2 minus x1, which would be x plus h minus x. And you can see there it is. Okay, so that's huge that you understand that. So make sure that makes sense. If it doesn't, then again, go back and listen to this. All right, so if that's the case, if this is the slope between these 2 points, we notice that the x minus x, they just cancel each other out. So we just have an h in the denominator. So this is a simplified form of the slope between these 2 points. Okay? All right, now, as I wrote here, think of the sliding the second point down towards the first point. Okay? So what we just did is we found the slope of this line between this point and this point. Okay? But if you think of this h, whatever it is we're adding to x, what if we slid it down a little closer to this point x? Because remember, what I'm ultimately interested in knowing is what is the slope of the tangent line at that point. Okay, so instead of it being here, what if that x plus h was here? So now it's x, okay, the point at which we really are interested in finding the slope of the tangent line. But now h isn't, we're not adding an h all the way out to here, it's just here. So we're sliding this point closer to the x value that I'm actually trying to find the slope of the tangent line. So think of sliding the second point down towards the first point. This was the first point, okay? The value of h continues to get smaller, doesn't it? So here was the value of h when we started, and if I slide it a little closer, then that value of h is smaller yet. If I slide it a little closer, that value h is smaller yet. Okay? So as that happens, the secant line now becomes, I should say, closer and closer to the tangent line. Okay? So if you look closely, here's the tangent line. Okay? Here's what our first secant line looked like. And as this h value becomes smaller, okay, you can tell that this secant line becomes closer and closer to the actual slope of this tangent line. Okay, so here it is, and here's where limits come into play. And hopefully, if you get this, then you get exactly what's going on. So we know that this is the slope that exists between these 2 points. Okay, so the slope of the actual tangent line would be this: the limit as h approaches 0 of the slope of these 2 points. So we're saying, so this is the point at which we're trying to find the slope of the tangent line on this curve. Okay, but ultimately we need to have 2 points. So here's the point at which we're trying to find the slope of the tangent line on the curve. Here's my second point, because I need to have 2 points. But I'm going to find the limit as h approaches 0. And we know from limits that if h is approaching 0, that means it's so infinitely close to 0 that it's as though it is 0. So that's how I get around finding the slope using the slope formula when I have to have 2 points. But that second point, we're going to find the limit as h approaches 0. So this is the formula that's going to find the slope of the tangent line. Okay, so let's turn and go to the next page. And with me here, my computer just froze. Okay. All right, so let's go to the next page. Got to have my computer on so I can see what you guys are seeing. All right. So we, not in class, we just now came up with the slope of the secant line joining the point x f of x, and then the second point, x plus h or x plus delta x, f of x plus delta x. So this slope, as we derived on the previous page, is this. Okay, so let's look at our first equation. So let's say the function's value is f of x equals x cubed. Okay, so we know, well, hopefully you remember, that it would look, this function looks something like this. That's what f of x equals x cubed looks like. Okay, so so if we wanted to find the slope using this formula, okay, so here it is. Here's the formula. Okay, we know that f of x equals x cubed. So f of x plus delta x, so I'm going to substitute x plus delta x in for x. So you can see there it is, x plus delta x cubed, okay, minus f of x. And f of x is x cubed. Those parentheses should really be around all of this, if we're going to put parentheses there at all. Okay, so f of x plus delta x. So I just took x plus delta x and substituted it in for x. So I have that cubed. Okay, and then all over delta x. All right, so next step. So hopefully you get this. I'm just plugging into the function itself. X plus delta x cubed. So that is an expansion of a binomial. And you guys, we've done this before. So I'm just going to go ahead and write out my Pascal's triangle. This is a binomial that is being cubed. So that means degree 0, 1, 2, 3. These are my coefficients. Okay. So 1, 3, 3, 1. And you can see them right here. 1, 3, 3, 1, 3, 3, 1. Okay, and then remember, so this is the binomial, so you start with the first term cubed. The second term is raised to the 0 power, so that's just a 1, it's not there. And then this descends, x cubed, x squared, x, and then 0. And the second term ascends, delta x to the 0, delta x to the 1, delta x squared, delta x cubed. So here's the expansion of my binomial, okay? And then minus x cubed. That stays the same, okay? All right, again, if you have to go back and listen to that for it to make sense, then please do that, because this is huge. Okay, so then I notice I have 1, 2, 3, 4 terms. X cubed minus x cubed, those two are just going to cancel. Okay, which leaves me with these 3 terms, which is what I still have right here. And that delta x is going to divide into each of those 3 terms. So they cancel there, so we're just left with 3x squared. One of the delta x is canceled here, so we have 3x delta x. And one of them cancel here, so now we just have delta x cubed. Okay, so this, all right, is going to be the slope of the tangent line for the function that we started with, f of x cubed. Okay, I want to see if I can pause this. So your turn now. So I want you guys to attempt doing this same thing, okay, with this one, and I'll be right back with you. If I can't pause, well, then I'll just post another video showing each of these.